Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. ଏଥିରେ ମୁଁ ଅଲରେଡ଼ି ପ୍ଲସ୍ ଟୁ ସେକେଣ୍ଡ ଇୟର ସିଲାବସ୍ କମ୍ପ୍ଲିଟ୍ କରିସାରିଛି। ଏବେ ମୁଁ ପ୍ଲସ୍ ଥ୍ରୀ CBCS ଫିଜିକ୍ସ ଅନର୍ସ GE ଆଉ MSc ଫିଜିକ୍ସ ଅନଲାଇନ୍ କ୍ଲାसेसର ଭିଡ଼ିଓଜ୍ ଅପଲୋଡ଼ କରୁଛି। ଯଦି ଭଲ ଲାଗିଲା ତାହେଲେ ଭିଡ଼ିଓଜକୁ ଲାଇକ୍ କରିଦେବ ଆଉ ଚ୍ୟାନେଲକୁ ସବସ୍କ୍ରାଇବ୍ କରିଦେବ। ୟୁ କ୍ୟାନ୍ ସେୟାର ଇଟ୍ ୱିଥ୍ ୟୋର୍ ଫ୍ରେଣ୍ଡସ୍ ଅଲ୍ସୋ, ଇଟ୍ସ କମ୍ପ୍ଲିଟଲି ଫ୍ରି ଅଫ୍ କଷ୍ଟ। लेटेस्ट वीडियो नोटिफिकेशन ପାଇଁ बेल आइकन को एठी ऑल रे सेट कर दबो। तापर वीडियोज रो क्लैरिटी बढ़ावा ପାଇଁ गो टू सेटिंग्स, क्वालिटी, एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन। सबू वीडियोज ପାଇଁ पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स। तापर मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो। ओके, थैंक यू। हेलो स्टूडेंट्स, आज टॉपिक रे आमे यूलर्स थ्योरम विषय रे पढ़िबा। ऑलरेडी आमे देखिला रिजिड बॉडी केस रे जनरलाइज्ड कोऑर्डिनेट रो संख्या होची 6। A rigid body needs 6 independent generalized coordinates to specify its configuration. So a rigid body can have two independent motion, गोटे हला translation motion बा translatory आ गोटे हला rotatory बा rotational motion. Therefore such a body in motion can be completely specified जेमती कहली 6टा generalized coordinate out of which 3 will specify its position and the other 3 will specify its orientation. Okay, so 3 coordinates, as I said, are needed to locate some point within the body on the instantaneous axis of rotation, and the remaining 3 will finally specify the orientation of the rigid body. Thus out of the 6 degrees of freedom jota ki 6 generalized coordinates, 3 degrees of freedom represents the translation motion or translatory motion of the body, whereas the other 3 describe the rotational motion. So above conclusion is in conformity with the Euler's theorem on rigid body motion, which we will state below. Okay, and तार proof मध्य आमे देखिबा. So Euler's theorem को एबे आसीबा. The generalized displacement of a rigid body with one point fixed is a rotation about some axis. बस एतिकी हला Euler's theorem. So as one point of the body is said to be fixed and we take it as the origin of the body set of axis. जो point टाको fixed बा constant हला ताको हमें body set of axis रो origin बोली की धरिबा. Then the body cannot have any translatory motion. Hence, according to this Euler's theorem, we can always obtain the body set of axis by means of a single rotation of the initial set of axis, which may be coincident with the space set of axis at the initial time. Now since we know that in a rotation the magnitude of a vector does not change, it a constant rahibo magnitude ta vector ro, so only its direction may undergo a change. So the problem therefore now reduces for finding the rotation axis such that the distance of the particles of the rigid body from this axis remains the same during the rotation. Okay, now from above it, now it appears that any vector lying along the axis of rotation must have the same components in the initial as well as the new set of axes which are obtained upon the rotation, and the magnitude of the vector jemti कहली it remains unchanged. Okay, suppose for example let us say the rotation be brought about by a matrix that is A, and if such a vector along the axis of rotation be capital R, then the transformed vector suppose याको आमे कहला r dash बा r prime must be identical with r, and we can write here r dash to be equal to ar, which is identical or equivalent to r. Now this equation is of the form ar equal to lambda r, where we have taken lambda to be equal to 1, which is called as nothing but the eigenvalue equation. How lambda hela gote constant, right? Now if we are able to solve this equation for the matrix A, that is we will find the eigenvalues, that is nothing but the lambda, and the corresponding eigenvector r will be found, then Euler's theorem can be proved. Okay, so this equation 2 can also be written as जो समय secular equation देखुथिलो small oscillation रे a minus lambda I r equal to 0 जो थे कि I हेगला identity by unit matrix. Okay, now this equation 3 याकू लक्ष्य करो, it constitutes a set of simultaneous homogeneous equation whose solution can also be found ଯେତେବେଳେ ଆମେ ଏଇ ସବୁ coefficient ର determinant को 0 करिबा माने the determinant of the coefficient vanishes, that means determinant a minus lambda I equal to 0. ओके याकू जदि हमें फुल फॉर्म रे लिखिबा ताले सेक्युलर इक्वेशन हमें पाउचू a11 minus lambda then a12 a13 a12 a13 तापर a21 a22 minus lambda a23 a31 a32 and a33 minus lambda. So this determinant 3 cross 3 should be equal to 0, which is the secular equation, right? Now eta hela jo 3 cross 3 determinant, it will give you a cubic equation solution re ame paiba in lambda, so that we will obtain three roots. Suppose hegala lambda 1 lambda 2 and lambda 3. Okay, yaku denote kariba suppose lambda k, where k is equal to 1 2 3. Okay, eta hela yara subscript. Now for each of these eigenvalue we can solve equation 3 in order to find the corresponding eigenvectors, that is r1 r2 r3. So the set of equation, suppose first jodi ame dekhla first solution lambda 1 tale accordingly ebe ei jaga re सब ame lambda 1 put kar dela into x11 x12 x13 should be equal to 0 ହେଲା एटा देखो एठी मैट्रिक्स रे हम याकू लिखिछु ताले एठी x11 12 13 कोन, these are the three components of the first eigenvector, that is r1. So similarly we can develop equation for r2 having components x21 x22 x23 and also for r3 with components x31 32 and 33. So these all equation together now will constitute a matrix which is like of the form ax equal to x lambda. ओके एटा याकू हमें लैम्बडा सिंबल कहि थाउ ए जो अछि मैट्रिक्स रे. सो x रो यारो वैल्यूटा हला अगेन अ 3 क्रॉस 3 मैट्रिक्स, दिस वन एटा हला जेमति कहिली लैम्बडा मैट्रिक्स which is having only elements along the diagonal, that is lambda 1 lambda 2 lambda 3, where the off diagonal elements are nothing but 0. Okay, now this equation 5, you see, let us now multiply on this equation 5 with x inverse. Okay, x inverse both side रे हमें multiply कर देले एठी याकू ये RHS रे कटि गला, right? x inverse x which is nothing but 1 ताले हमें पाउछु केते x inverse ax equal to lambda. Okay, so here already indicated that lambda is nothing but a diagonal matrix जेमति हमें यारो फॉर्म टा देखुतिला, whose diagonal elements are nothing but the roots or the eigenvalues which are lambda 1 lambda 2 lambda 3 of the matrix A. So equation 6 now represent the diagonalization of the matrix through a similarity transformation. Okay, and the matrix X that diagonalizes the vector A has along its columns the eigenvectors of A and the elements of the diagonalized form of A which are corresponding eigenvalues. Okay, acha ebe kono kariba, in order to represent a rigid body rotation, the matrix A that performs this rotation has the following properties. Okay, number 1, it must be an orthogonal matrix. Okay, orthogonal matrix kaiki, because it leaves the magnitude of any vector unchanged, fixed रहिबो. That means a tilde ए जो ऊपर सिंबल ए भले अछि याकू कहा जाय tilde, a tilde should be equal to a inverse. Then second property कहउछि, as the time advances or progresses, the orientation of the body will change and the matrix of the transformation will be a function of time. That is equation रे लिखले a should be a function of time t, and since the transformation must be continuous, it must evolve continuously from the identity transformation. Then the third property further, the matrix AT, which is the function of time, must correspond to a proper rotation. That means its determinant must be equal to +1. We also know that determinant of the transpose of A, which is equal to A tilde, will also be equal to +1. That means determinant ଆମେ ଯଦି ଲେଖୁଛୁ of A or A tilde should be equal to +1. Okay, so let us now consider the expression A minus I into A tilde. ତାହେଲେ ୟାକୁ ଆମେ ଲେଖିପାରିବା I minus A tilde. Okay, ୟାକୁ ଏବେ solve କରି ଯିବା. So we are getting a situation like this: A minus I, A determinant ହେଇଯାଉଛି ସମାନ determinant of minus of A minus I. That means the determinant of the matrix A minus I is the same as the determinant of its negative. Okay, negative sign লাগিଛି ନା? So if n is the order of the square matrix, then this means A minus I ଏବେ ହେଇଯିବ କେତେ? ଯଦି order ହେଇଗଲା n, that means ଏଟା ହେଇଗଲା -1 to the power n A minus I. যদি ଗୋଟେ 3 dimensional space ନଉଛୁ ତାହେଲେ n ର value ହେଇଗଲା 3. So it satisfy only when A minus I is equal to 0 determinant. Okay, so comparing this with the secular equation, that is equation 4, it is evident that one of the eigenvalue lambda must be +1, and this completes the proof of the Euler's theorem. Okay, जोटा कि हमें देखला जे गोटे eigenvalue निहाती भाबरे +1 हेबो ही हेबो. Okay, which is the proof of the Euler's theorem. Okay,
Thank you.